Photodiode. What is a photodiode? Is defined as a PN junction or PN semiconductor device that consumes light energy to generate electric current. Is also sometimes referred as photodetector, photosensor, or light detector. This is the symbol of a photodiode. So light is falling on the junction of a PN junction diode. Photo means light. So light is energy. So the light signal is converted into electrical signal. So the light energy is converted into electrical energy. This is the structure of a photodiode. The simple PN junction diode is taken. So N type has got majority carriers electrons and the minority are holes. Majority carriers are shown in blue color and minority carriers are in pink color. Right? Now P type also has got holes. The holes are represented in pink color and minority carrier electrons are represented with blue color. So when the electrons, this is the depletion here, doesn't have any charge. When the electrons are moving from N type to P type, there would be an electric field exists which has across the depletion layer. So this electric field has got a sign plus and minus. Right? When light, this depletion layer have the neutral atoms. When light is focused through the lens on the depletion layer, so electron hole pits, there will be neutral atoms and the electron hole pits will be ejected out from N type to P type. This is, so the covalent bonds are there in P type and N type, but strength of covalent bond is very less in the space charge region, that is the depletion region. Now, when covalent bonds are getting breakdown, it releases free electrons and free holes. So, breaking of covalent bonds due to light generates current. So, in photodiode, light generates current. This is very, very important. What is a photodiode? Photodiodes are specially designed to operate in reverse bias condition. So, we have N-type electrons, N-type electrons and P-type holes. Electrons are the majority carriers, so they move from N-type to P-type, and it leaves charge. It leaves in the depletion layer. We have electric field on the N-type with a sign positive and P-type with a sign negative, and it is connected. P-type is connected to negative of the battery, N-type is connected to positive of the battery. So the positive is in reverse bias. Under reverse bias, what happens? The minority carriers are repelled in N-type. Similarly, these holes are repelled and P-type electrons are repelled. As a result, when light is falling, the charge carriers are increased. So this PN junction depletion layer is unused department. It has neutral atoms. To increase electric current and the reverse bias current, we need to generate more minority carriers. So in reverse bias, more minority carriers will be generated in P-type as well. So in the end, the minority carriers are holes. These holes will support the neutral atoms that are present in the depletion. Similarly, P-type has got minority carriers has the electrons. These electrons will support the carriers across the neutral atoms as negative unmobile charge carriers will support the minority carriers of P-type will support that. So how it works? N-type and P-type. So, minority carriers have holes in N-type. The electrons and the majority carriers P-type this. The minority carriers generated N-psi or P-psi will recombine, so in same material before they cross the junction. So the minority carriers will recombine with the holes majority carriers that are present, so will recombine in the same material before they cross the junction. So however, before crossing the junction, what happens? The free electrons recombine with the holes within the same material, right? So majority and the minority carriers, they recombine. As a result, no electric current flows. To overcome this problem, we need to apply external energy directly to the depletion region to generate more charge carriers. So what's the energy? Light is the energy. So the increase in the minority carriers P side and N side due to reverse bias, they increase. The generation of charge carriers will be more. So a special type of diode called the photodiode, which is designed to generate more number of charge carriers in the depletion region. So a photodiode continually operates in a reverse bias mode. The characteristics of the photodiode shown in the figure, that the photocurrent is nearly independent of the reverse bias voltage which is applied. For zero luminance, the photocurrent is almost zero, excluding the small dark current. It is often of the order of nanoamperes. An optical power rises, the photocurrent also rises linearly. Therefore, the maximum photocurrent is incomplete by the power dissipation of the photodiode. In forward bias, anode current flows in terms of milliamps. Current due to the light is there in terms of microamps. So the relative current due to light is negligible, so we don't use photodiode in forward bias. In reverse bias, current in absence of light is due to the minority carriers, electrons and in p-type and holes in n-type, and that is known as dark current. And the dark current is nothing but the reverse saturation current. In forward bias, anode current flows in terms of, and the current is due to the microamps, and relative current is due to light is negligible, and we don't use the photodiode in forward bias. This is very, very important. This is the reverse bias condition and the characteristics in reverse bias. And applications: compact displays, smoke detectors, and space applications. Photodiodes are used in medical applications too, such as computed tomography instruments to analyze the samples and pulse oximeters. Thank you.